Hello everyone. So once again, I welcome you all on the YouTube channel of TEQIP GATE classes. Uh, TEQIP GATE classes. So this is all about me, and we were discussing about the unconventional machining. And in the last lecture number 22, we started the electrochemical machining operation, and we discussed the principle and how it is work. What are the reactions that is involved in when we are using the different types of the electrolytes like water and the salty water. We also discuss about the properties or the characteristics that is required uh, for the ECM tool as well as the electrolyte, and we also discuss about the material removal rate. Okay, so little amount of the theory is remaining there, means some calculation part formulas, so that we are going to discuss first, and then we'll take the numerical problems. Okay. So first is the gap resistance. Okay, so what is the gap resistance is, if for an example, if we are using the two electrodes, okay, which is inside the container, okay, this is filled with the electrolyte, so this circuit is completed. Now what is happening is that what is happening is like we are, as we are supplying the current, initially we are maintaining some gap. Okay, so as we said in the last video that we are when we talk about the 100% current efficiency, so that time I told you that whatever the heat is generated over here, that is completely absorbed by the workpiece. Okay, means we are not like initially we have maintained some gap, and after some times will give the feed to the tool, and then only it will start depleting the material from the workpiece. It's not like that. Initially whatever the gap is maintained, okay, minimum resistance for that we needed, we are maintaining, from that only we are starting. So that what is the value of that resistance? Okay, so that will be equals to, that is R, capital R will be equals to small r. What is this? I will tell you, don't worry. As H upon S. Okay, now this small r is the, capital R is basically the gap resistance, small r is basically the specific resistance of electrolyte. Okay, and the unit is, that is ohm into centimeter. Please keep in mind this one as well. Okay, so this is the resistance, the specific resistance. Okay, H is the minimum gap that is required initially, minimum gap that is required initially. Okay, that is in centimeter, or if it is given in mm, then you can convert it into the centimeter. Okay, or this value also you can convert in mm, that depends on our comfortness. Okay, so next is S is basically the surface area, F is basically the surface area, or we can say it's a cross sectional area. Cross sectional area means this is the workpiece. For an example, this is the workpiece and this is tool. Okay, so it has this cross section, it has some width and it has some cross sectional area. Okay, because this is the gap, and this surface area is the only part which is in front of this tool. Okay, so when this tool will we give the, initially we are keeping the minimum resistance, so material will start depleting from this range only, means this cross sectional area only. Okay, if this complete cross sectional area, like if this complete cross sectional area is in front of the tool, complete cross sectional area, then material will start removing from itself only. Okay, so that is the cross sectional area. So please keep in mind this formula, that R will be equals to small r into H by S. Okay, next is the density of the alloys. Density of the alloy means, last time we discussed in the material removal rate that MRR will be given as, that is I into A upon rho into capital F into V. So rho we took as a density, and that density of the material. But for an example, if all of you are aware about that this workpiece here we are using is we are using it as a tool in the conventional machining operations. Okay, so if this is the tool exactly, means it has a very high strength, no doubt that material itself contains the number of materials, means it is basically, it's not a single material, it's a alloy. Okay, it's a combination of multiple materials. So if how we calculate that density, if we say that x1 is the percentage for the first material, x2 is the percentage of the second material, then how we will calculate? So for that, we have to calculate, we have to put this value, that will be equivalent value. Okay, if it is a alloy base, then this density is not for the single material, it is for the alloy. So how we will calculate this equivalent density? So for this, the formula will be equals to 100 by rho equivalent. Okay, that will be equals to x1 by rho 1 plus x2 by rho 2 plus x3 by rho 3, and like this. If there are n number of the material, then similarly we are adding. X1 is what? X1 is the percentage of the what material we are using. Okay, means how much percentage of the first material we are using. Okay, and rho 1 is the density of that. X2 is the second percentage of the second alloy. Okay, for that the respective density is rho 2, and similarly for the third part. Okay, like this we can calculate this rho equivalent, and then we will put this value over here. Fine. Another term is like if there are like three, if alloy is made up of the three different types of the material. Okay, then first, second, and the third one, then no doubt if no doubt then the atomic weight of this material will also be different, because for iron it is different, for nickel it is different, for cobalt it will be different. So if A is different, then obviously V valency will also be different. So it means A by V is what? We initially, when we find out this equation that M is directly proportional to Q into A by V. So A Q was the charge passed, but what was A by V? It is basically the electrochemical equivalence. Okay, so if it is a single material, then we can take that A for that and V for that. But if it is a alloy, then no doubt it is a it is not. We have to find out the value of E equivalence. Okay, so for how we will find out that value? That will be equals to 100 by E equivalence. Okay, E equivalence, and that will be equals to x1 by E1, x2 by E2 plus, sorry, x3 by E3. Okay, like this we can calculate. Now E value is representing to what? A by V. So like this also you can write this equation, that is A1 by V1. So V1 will move towards in the numerator part. So this will x1 into V1 by A1, x2 into V2 by A2, and this will be x3 into V3 by A3. Like this we can make it. Okay, so this will be like this we can calculate the value of E equivalent. So if there will be a discussion over the material removal rate, then no doubt this equation will become, this will become I into E equivalence upon rho equivalent into F, because A by V that is already taken into equivalent part. Okay, so this will be the material removal rate for an alloy. Please keep in mind this one. Okay, next one is two more things is remaining, that is flow analysis. In this ECM analysis, this flow analysis is completely depend on how much amount of heat is transferred. Okay, how much amount of the heat is transferred. So heat that is generated due to the potential difference, that will be equals to I square into R. Now why it is depends on the I and the R only, why it is not depend on the V? That is, in the last time we discussed in the process parameters that voltage value in comparison with the I is very less. Okay, and here we need very, means we highly needed the value of R, that is the gap resistance. So that's why we are whatever the heat is generated, that is calculated through the I square into R. This is the first equation. Second is how much amount of the heat is generated, how much amount of the heat is absorbed by the electrolyte. Okay, because of that only the material is start releasing, means ions start displacement. So how much amount of the heat is generated? So that will be equals to M into CE into TB minus T naught. Okay, so this will be CE is nothing but the specific heat capacity. Okay, and this is the boiling temperature or boiling point. This boiling point is in degree centigrade. This is the ambient temperature. that will be in degree centigrade, and this is the amount that how much flow is takes place. Okay, how much flow is takes place when we have the density of the electrolyte. Okay, means q, if we are saying that q is the flow rate, then that will be q into rho into e. Okay, so rho into e. Now this rho e is not a part of the material, but it is the density of the electrolyte, density of electrolyte. Okay, and q is basically the flow uh, flow rate. Okay, this is the flow rate. Okay, so please keep in mind this one. Now is when we were deriving the material removal rate, okay, that time I have taken these I have spoken these things so many times, that MRR, when we took this MRR, we consider the 100% efficiency. Okay, 100% current efficiency. It means that whatever the heat is generated there, that is completely absorbed by the electrolyte. Okay, or electrolyte. So this will be equals to, if it is 100%, then we can write that this is I square into R, that will be equals to Q into rho into E into CE into TB minus T naught. Please keep in mind this one. This formula is only it will be equal when there will be a 100% current efficiency. If it is not, then we have to take accordingly. Okay. Now the feed rate is nothing but we are providing this tool speed. Okay, tool so that will be depends, that will be equals to MRR, that is material removal rate, upon surface area. And this surface area is the same that when we are taking this R, when we are calculating this R gap resistance, that we are taking small r into h by s. So this s is the surface area or the cross sectional area of the workpiece that is coming in contact with the workpiece, or through which the material is depleted. So this area, surface area, will be same over here. Okay, so that will be, feed rate will be equals to MRR upon surface area. ठीक है, so यही theory part था. ठीक है, now we'll come to the numerical part. ठीक है, so let's start the numerical that has been asked in the GATE examination 2009. So electrochemical machining is performed to remove the material from an iron surface of 20 by 20. Okay, means आपको cross sectional area दिया है ये. ठीक है, 20 by 20 under the following conditions, that inter electrode gap is 0.20. तो यहाँ मैं लिख देता हूँ उसको, that H will be equals to, that is 0.20 mm. ठीक है, the supply voltage, that is as I already mentioned, that we are using the DC only, so that is 12 volt. Okay, the specific resistance of the electrolyte, means small r is given to you, that is 2 ohm into centimeter. Fine. Atomic weight of the iron, so capital V is given, A is given to you, that is 55.85. और अगर आपको नहीं दिया होता है तो प्लीज आप 56 इसको कंसिडर कर सकते हैं. ठीक है, valency of the iron is given to you, that is small v, that is equals to 2. Okay, Faraday's constant, that is capital F, is given to you, that is 96,540. okay, coulombs. अगर नहीं दिया होता तो हम लोग 96,500 कंसिडर कर सकते थे. ठीक है, the material removal rate that we have to calculate, that is MRR, we have to calculate, and that is in gram per second, not in cc per second. So देखिए density की जरूरत नहीं है यहाँ पे. ठीक है, so how the MRR will be equals to, this MRR will be equals to I into A upon F into V. Okay, तो देखिए A, that is atomic weight of iron. देखिए एक single material है. ठीक है, atom alloy नहीं है, so because iron surface given है ना initially, and valency and atomic weight is given to you for that iron. So A is given to you, V is given to you, capital value F is given to you. Okay, but I is not given to you. So how we can calculate the value of I? So for I will be equals to sorry, we have V equals to I into R. So from this we can get the value of I. So this will be equals to V by R. V is what? The DC supply, means voltage that we have given, and R is basically what? The gap resistance. But again, V is given to you, but R is not given. So we can get the value of R. So how we will get the value of R? That will be equals to small r into H by S. So small r is given to you, that is specific resistance. Yes. H is given to you, the minimum gap. Yes. The surface area that is given to you, that is 20 by 20 given to you. So that is from that you get the surface area. So this is basically the approach. Okay, so please, whenever you are doing the numerical problems or the problems from the GATE examination or engineering services examination, you should apply this approach. Okay, whatever the formula is given to you, just try to imagine and write it over there, and try to fill it that how we can get the value which is not available to us, and what are the formula others are available to get that value. Okay, please keep in mind. So from here you can get the value of r. You can put this value r over here. From here you will get the value of I, and put this value I over here. So you will get the value of MRR. फाइन. तो पहले हम क्या करते हैं, आर कैलकुलेट करते हैं. तो आर विल बी इक्वल्स टू स्मॉल आर इंटू एच बाई एस. ठीक है, तो स्मॉल आर की वैल्यू कितनी है आपकी 0 पॉइंट सॉरी स्मॉल आर की वैल्यू है आपकी 2 ओम इंटू सेंटीमीटर. ठीक है, एच कितना है आपका, दैट इज 0.20 mm. ठीक है, 0.20 mm अपॉन सरफेस एरिया कितना है आपका 20 इंटू 20, तो mm में है, सो दिस विल बी 20 इंटू 20. बट देखिए यहाँ पे आपको यहाँ पे h आपको mm में गिवन है, और s जो है आपको अगेन दैट इज आल्सो इन mm स्क्वायर. सो इट वुड बी बेटर दैट दिस इज इन ओम इंटू सेंटीमीटर, सो कन्वर्ट दैट इंटू mm. ओके, तो आपको दो की जगह एक को ही कन्वर्ट करना रहेगा. सो व्हेन यू विल कन्वर्ट दैट 2 सेंटीमीटर इंटू 2 ohm into centimeter to 2 ohm into mm, so just multiply with the 10. Okay, so from here you will get the value of r, and the value that I am getting is that is 0.010 ohm. Okay, so that this is the value of r. So now from here you can get the value of I, so that will be equals to V by R. So what is the value of V? That is supply voltage is 12 volts. So this is 12 upon 0.010. So when you will calculate this value, this will be equals to 1200 ampere. Okay, because the range that we have to keep in mind, the current range is 500 to 40,000 ampere. So here we are using 1200 ampere. ठीक है, please ध्यान रखिएगा. So next is all the values is given and we have calculated. So just calculate the value of MRR, that is I into A upon F into V. So I is now it's 1200 into A is how much? A is 55.85. Okay, upon F, that is 96,540 into V is how much? That is 2. So just get the value. So when you will calculate this value, I have also calculated. So I am getting that is 0.3471 gram per second. Okay, so this is the value that I am getting. Okay, so the option will be in gram per second only we have to calculate. So the option will be A. Fine. Okay, so let's move to the next problem. This problem is not asked in any of the examination yet, but it is a conventional problem, that's why I have taken this problem. Okay, so if for an example this kind of problem can be asked in GATE examination as well as it is a conventional problem, so there's a possibility to ask in the engineering services examination as well as administrative services, so you can go through it. Okay, so I'm taking, don't worry. Okay, so let's take this problem. Okay, so the electrochemical machining of an iron surface, again a single material it is they are talking about. Okay, so iron surface that is 25 by 25 mm in cross section using NaCl in water as electrolyte. Okay, so here we are talking not only taking the salt simple water, but we are taking as a we are taking salty water. Okay, okay, so the gap between the tool and the workpiece is 0.025, means here the surface area is given to you, that is 25 into 25 mm square. Okay, then next is the value of H is given to you, that is 0.25 mm. Okay, the next is the voltage, supply voltage is 12 volt, that is DC, so the value of V is given to you, that is 12 volt. Okay, the specific resistance of the electrolyte is 3 ohm into centimeter, so the value of small r is given to you, that is 3 ohm into centimeter. Okay, ohm into centimeter. Estimate the material removal rate in kg per second. Okay, देखिए अभी तक हम लोग generally gram per second में calculate करते थे, but right now it is asking that in kg per second. The feed rate, that is the material removal rate upon surface area, we have to calculate, that is in mm per minute, and the electrolyte flow rate. Okay, that is value of Q we have to calculate, that is in centimeter cube per second. Okay, the specific heat of the electrolyte is given as 0.997 calorie per gram into degree centigrade. The ambient temperature is 35 degrees centigrade, means the value of TO is given to you. This is value of C is given to you. The electrolyte boiling temperature is 95 degrees centigrade, means TB is given to you. The density is given to you, that is obviously this density is not of the electrolyte, because generally liquid do not have this much density. So this density is of the iron only. Okay, so this is rho E is given to you. Sorry, rho of iron. Okay, Fe is given to you. Okay. Now, what we have to calculate first, we have to calculate the material remole rate. So, for the calculation of the material remole rate, what we can write, material remole rate will be equals to I into, we have to calculate in kg per second. So, no need of rho, I into A upon F into V. Okay. So, V is the valency, okay, which is not given to us, but it is for the iron. So, I told you in the last problem as well that if it is not given, just consider it 2, and the atomic weight will be 56. Okay, so this is given to you now. F is the Faraday's constant. If it is not given, then we will consider it's 96,500, and I is the current. So I is not given to you. Okay, but as I said, आप में आपको इसमें से दिया तो कुछ भी नहीं है, but F is the constant. A and V is also not given, but iron is given to you, so we are assuming that values. Okay, so we have to calculate, because that is also not given. So how we will calculate this I? In the last problem, how we calculated, that is I equals to V by R. V is what? That is the supply voltage, and R is what? The minimum resistance, the gate resistance, and that is also not given. So the same condition how we calculated in the last problem, that is R will be equals to small r into H by S. So till the calculation of MRR, whatever the steps that we followed in the last problem, same steps we have to follow in this problem as well. Okay, so because for this, small r is given to you, H is given to you, S is given to you. So get the value of R, put the value V by R, get the value of I, and put the value there. Okay, so just put the value of R, means get the value of R. So that will be equals to small r. Small r is how much? 3 ohm into centimeter. So again, H and S in mm is given to you. So just convert this in mm as well. Okay, so this will be ohm into mm. Okay, H is what? The gate. Okay, and that is given, that is 0.25 mm. Okay, upon the surface area, and surface area is what? That is 25 into 25. So this will be like 25 into 25. Okay, so this is in mm square, this is in mm, this will, we have converted this is in mm. So from this we can get the value of R, and this value that I am getting is, that is 0.012 ohm. Okay, so this is the value of R, means the gate resistance that we are getting. So put the value of R over here. So I will be equals to V by R. Okay, and the V will be equals to 12, and R will be equals to 0.012. So from here you will get the value of I, and that will be equals to 1000 ampere. Obviously it is greater than 500 ampere, and that the range that we consider, that is above 500 and in between the 500 to 40,000 ampere. Okay, so that is the range, means that is the current that we are using, and we can get the value of R MRR from here. So that will be equals to I, that is 1000 we have calculated, into A is 56 upon F, that is 96,500 we are writing, and the valency is 2. So from here we can get the value of MRR, and that will be equals to what I am getting is, that is 0.290 gram per second. Okay, but this value we are getting in gram, so this will not be the answer. Answer will be needed in kg per second. So just convert this gram into kg. So that will be equals to 10 to the power minus 3. Okay, so this MRR will be equals to 0.290 into 10 to the power minus 3 kg per second. Okay, so this will be the answer. But this is first answer. We still have to find out the two answers. Okay, so first answer is this. Now second, we have to find out the feed rate. Okay, so for the feed rate, we can calculate that feed rate will be equals to MRR, that is material removal rate, upon surface area. Okay, surface area. Okay. Now surface area, that is in mm square, that is 25 into 25, and the material removal rate that we calculated, that is in kg per second. Okay, so what we have to do, we have to first convert this into mm cube per second. Okay, because then only we will get this, because feed rate is required in mm per minute. Okay, so for this we have to convert this material removal rate into mm cube per minute. Okay, so for that what we will do is, we can get the value of, okay, let's try. So this MRR will be equals to, MRR will be equals to, that is 0.290 into 10 raised to power minus 3, okay, upon density, because when you will divide the density, that you will get the value of that in mm cube per minute. So here it will be like, this is 7860, that is in kg per second, or here it is kg per meter cube. So this will be cancel out, and whatever the value that you will get it over here, that will be in meter cube per second. Okay, so when you will get the value, this value I am getting is, that is 3.6896 into 10 raised to power minus 8. Okay, that is in meter cube per second. Okay, so this is the MRR, that is in meter cube per second. Okay, so just put the value over here. So when you will put the value over here, this will be like 3.6896 into 10 raised to power minus 8, और देखिए अपॉन, देखिए mm cube में है. Okay, so this is in like here this is in meter cube. ठीक है, तो meter cube में इसको रहने दीजिए, like but यहाँ पे second है तो इसको minute में convert कर दीजिए. So this will be like upon divide with the 60. Okay, so that, sorry, multiply with the 60. Okay, now bottom part, that is 25 into 25, so this is mm square, so just multiply by the 10 raised to power minus 6. Okay, so this will be like 10 raised to power minus 6, or is whatever the value that you will get it over here, that will be in meter. Okay, so meter per minute. So from here what the value that I am getting is, that is just multiply this with the 1000 as well. So whatever the value that you will get it, that will be in mm per minute only. Okay, so what the value that I am getting is, that is 3.54 mm per minute. Okay, so this is the value that I am getting. Okay, so this will be the feed rate. Fine, and we have to calculate in mm per minute only. So this is the value. Okay, next is the electrolyte flow rate. Okay, so this is in centimeter cube per second. So how we will get the value of Q? So heat generated, or sorry, heat absorbed by the electrolyte, that will be equals to Q into rho E into CE into TB minus T naught. Okay, and is also we discussed that whatever the heat is generated, that will be equals to I square into R. If nothing is given that what is the efficiency of the current, then we will assume that will be 100% efficiency, and this will be equals to I square into R. Now we have to calculate the value of Q. So from here the Q will be equals to I square into R upon rho into E, sorry, rho E into CE into TB minus T naught. What is these values are? I, that is the current, R is the gap resistance, rho E is the density of the electrolyte, CE is the specific heat capacity of the electrolyte, TB is the boiling point of the electrolyte, and T naught at which the ambient temperature. Okay, so I is we have already calculated, R we calculated, rho E is not given to you, but we know the value. CE is given to you, TB is given to you, T naught is given to you. So from this we can get the value of Q. Okay, so just put the value, that is put the value. I have also calculated this one, so put the value over here. Also please keep in mind that density of the electrolyte, if here for the iron best suitable that electrolyte is we are using, that is 1.0 gram per cc. Okay, please keep in mind this one. Fine, so just put the value, that is I, that is I is this is 1000 and R is 0.012. Okay, so this is 1000 square into R, that is 0.012, okay, upon rho E, that is 1 into CE, how much CE is given to you. And please keep in mind the unit as well, that is in calorie per gram into degree centigrade. So that is, we are already taking that gram per cc, so gram will be cancelled out, okay. So that will be equals to 0.997 into TB. TB is how much? That is 95 and this is 35. Okay. So that will be equals to 95 minus 35. Okay. So this will be equals to Q. So whatever the value that you are getting, like from here, this is gram per cc. So cc will be going there, and whatever the value that you are getting, that is in gram per cc per second. Okay. Okay. So that will be equals to, when you will calculate this value, I've already calculated. So what value I'm getting is, that is 47.922 cc per second. Okay. So please keep in mind this one. Okay, why we are keeping this second? Because whatever the value that we are taking, I and R, that we have calculated that when we calculate this MRR, for this we calculate this MRR, that is in gram per second. Okay, so that's why that's why we are keeping it in second only. Okay, cc per second. So please keep in mind this one. Okay, so this type of problem, individual problems, can be asked in the GATE examination, because this problem itself cover the three problems. Okay, so if I say that अगर मान लो कि जो पिछला क्वेश्चन हमने किया है, जो गेट में पूछा गया था 2009 में, this problem is completely the first problem what we have calculated over here. Okay, that is the first problem. मान लीजिए कि अभी तक सेकंड प्रॉब्लम और थर्ड प्रॉब्लम जो इस पार्ट में है अभी तक पूछी नहीं गई है, तो देयर इज अ पॉसिबिलिटी दैट कि गेट में भी पूछी जा सकती है इन फ्यूचर. ओके, एंड फॉर द ईएस एंड एडमिनिस्ट्रेटिव सर्विसेज, दिस कंप्लीट एग्जांपल इज अ बेस्ट सूट. ओके, definitely it will give you 15 to 20 marks. One more problem that we are going to discuss, and next problem is there that I will give you in the homework part. Okay, so a researcher conduct electrochemical. This problem is asked in the GATE 2008, that is conducted by IISc Bangalore. A researcher conducts electrochemical machining operation on a binary alloy. Binary alloy means two materials are there. Okay, means the combination, the alloy which is made up, that is combination of two separate materials. Fine, binary alloy. So the density of this is 6000 kg per meter cube of iron. Means first material is iron and atomic weight is 56 and the valency is 2 of that, we know that. Okay, and another metal is there, that is metal P, which has the atomic weight, this is 24 and the valency is 4. Okay, now we have Faraday's constant is 96,500 coulomb per mole. Volumetric material removal rate of alloy is 50 mm cube per second. Okay, please keep in mind this unit. Okay, at the current of 2000 ampere, the percentage of metal P in the alloy is closest to, means when we are getting the volumetric MRR, material removal rate, at 50 mm cube per second, that time how much percentage of the P alloy we are using. Okay, so that is the question. So we know this, how we calculate this material removal rate for the alloys, that will be equals to I into E equivalence, okay, upon rho equivalent. Okay, because that is in mm cube per is given to you, so no doubt we have to consider the rho value as well. Okay, so rho is given to you, and into V, sorry, into F. Okay, now but listen, please keep in mind that a researcher conduct electrochemical machining operation, machining on a binary alloy which has a density of 6000 kg per mm cube. मतलब आपको इसमें डेंसिटी इक्विवेलेंट कैलकुलेट करने की जरूरत नहीं है, इट इज ऑलरेडी गिवन टू यू दैट जो बाइनरी अलॉय है उसकी जो डेंसिटी है दैट इज 6000 kg per meter cube. So there is no need to consider this, means no need to calculate this one individually, because this is directly given to you, that is 6000 kg per meter cube. Please keep in mind. Okay, so only we have to calculate this E equivalent. So how we calculate this E equivalent? That will be equals to 100 by E equivalent ओके आपका दो एलिमेंट्स हैं, सो दैट x1 इंटू v1 बाई a1 प्लस x2 इंटू v2 बाई a2. सो पहला एक काम करिए, दिस इज जस्ट कंसिडर इट फॉर द fe एंड दिस वन वी आर कंसिडरिंग फॉर द p मेटल. ओके तो अगर मान लीजिए x के लिए है, सो दिस इज द x परसेंटेज ऑफ द fe एंड दिस इज द वैलेंसी ऑफ fe एंड दिस इज द एटॉमिक वेट ऑफ fe and this is the x percentage of p metal, valency of p metal and this is atomic weight of p metal. Okay so this will be like हमें किसका कैलकुलेट करना है, परसेंटेज ऑफ मेटल p. तो देखिए इसमें ऐसा है कि लाइक जो अलॉय बना है दैट इज द कॉम्बिनेशन ऑफ बोथ द मटेरियल्स. ठीक है तो हम ऐसा मान लेते हैं कि लाइक दिस x metal x percentage of the p plus x percentage of the fe that will be equals to 1. ठीक है तो what we have to calculate, we have to calculate the percentage of metal p. ठीक है तो metal p कैलकुलेट करना है तो हमें xp कैलकुलेट करना है फॉर एन एग्जांपल. ठीक है तो हम क्या करें कि x fe की वैल्यू को भी क्या करें हम लोग 1 minus xp में रख दें. ठीक है so whatever the value that we will get at the end that will be a percentage of p only. Okay so that will be x fe will be equals to 1 minus xp into valency of fe that will be equals to 2 upon this is 56 plus this is xp and this will be 4 upon 24 that will be equals to 100 upon. देखिए अब whatever the here the value that we are getting okay at the end. देखिए अगर मैं मान लूं कि क्योंकि यहाँ पे अगर वैल्यू मुझे गिवन नहीं है तो अगर मुझे वैल्यू गिवन नहीं है एंड आई एम कंसीडरिंग दैट व्हाटएवर द वैल्यू दैट वी विल गेट दैट विल बी इन पॉइंट्स. ठीक है ऑब्वियसली पॉइंट्स में ही मिलेगी तो यहाँ पे मुझे 100 लिखने की जरूरत नहीं है. ठीक है अगर मान लीजिए कि पॉइंट्स में ना मिल क्योंकि एनी हाउ आई हैव टू मल्टीप्लाई विद द 100 at the end. Okay so please keep in mind this one. Okay अगर मान लीजिए कि if you are getting this value at the end that is in percent points. Okay अगर आप यहाँ पे पॉइंट्स में ही रख रहे हैं इन वैल्यूज को तो यू कैन पुट डायरेक्टली हियर 1 एंड इफ यू आर कंसीडरिंग दैट व्हाटएवर द वैल्यू दैट यू आर गेटिंग दैट इज ऑलरेडी परसेंटेज इन द परसेंटेज लाइक ग्रेटर देन 1 मींस 25 मतलब 75 या समथिंग लाइक व्हाटएवर द परसेंटेज इज देयर so that time you can consider this 100 but here I know that whatever the value that we will get that will be in point so that I'm writing over here 1. Okay upon E equivalent. So now from here you can get the value of E equivalent and this will be equals to what I am getting is that is 1 upon that is 0.0357 sorry 3571 plus 0.13096 into xp. Okay so from here means first of all what you have to do you just divide this one then this one and just take this value over this side. Okay bottom side so when you will get this E equivalent. Now getting one more page. Okay so once this is completed just put this value over here. So when you will put this value this will be like 50 into mm cube per minute mm cube per second. So as this density is given in meter cube so what I'm doing is I'm just converting this one into meter cube. So when you will convert this in meter cube this will be like 10 raised to power minus 3 cube. So this will become 10 raised to power minus 9. So this will be equals to I is how much sorry I is 2000. Okay so this will be 2000 into E equivalent so that will be equals to 1 upon this value. What the value is 0.03571 plus 0.13096 into x p. Okay so this is the value of E equivalent upon F that is 96500. Okay और तो कुछ नहीं है. Okay so apart from this one sorry for the comments. This is the E equivalence that we are getting. Okay so just put the value over here. So when you will put this value okay so that will be like that is the value of F and you have to take this value of rho as well over here. Okay so the value of rho that is density that is in 6000. Okay but So just put the value over here, that is 6000. But please keep in mind that whenever we are taking this value, that is in gram per meter cube. So meter cube we have already took it over here. Either we can convert in mm cube. Okay, अगर इसको आप हम mm cube में रखते हैं, so we can convert this in mm cube. So but now we have converted, so no need. But here that is in kg, so we have to convert that into gram. So that will be into 10 raised to power minus 3. Okay, so what you have to do when you will calculate this one, like you can keep this value over here in this direction, that is 0.03571 plus 0.13096 into xp, and you can keep this value over here in the side, and you can multiply and divide over here. So whatever the value you will get it from here, just put the value over here, and xp will be equals to, that is 0.2548. So that's why I told you there that whatever the you will if you will keep there 1, okay, so if you will keep here is 1, then the at the end this value will be uh, in points only. Okay, so now you can say that how much percentage is needed, so just multiply with the 100. So at this time this will be equal to 25.48. okay, so this will be the percentage of p metal. So the options is 40%, 25, 15 and 20, 79. So the nearest option is 25. Okay, so this is the right answer. Next problem is a wonderful problem. This is also not has been asked any of the examination, but this is a wonderful problem. So it can, there is a possibility that in the engineering services or gate examination can be asked. But similar pattern, this problem has been asked in gate examination in 2008. Okay, this was the similar problem. But इसमें क्या था कि इसमें सिर्फ this was based on the binary material, but here it is a quarterly material we are taking, मतलब 4 different metals we are taking. Okay, so 4 metals के लिए there is a possibility that engineering services हो या फिर administrative services पे ये पूछा जा सकता है. ठीक है, तो इसमें आपको क्या है कि अभी तक हम इसमें आपको कैलकुलेट करना है, कैलकुलेट द रेट ऑफ dissolution means feed rate आपको कैलकुलेट करना है. जस्ट मैं आपको थोड़ा सा ब्रीफ कर देता हूं, बट दिस इज फॉर द होमवर्क ओनली. फीड रेट जो है वी कैन कैलकुलेट थ्रू दी MRR अपॉन दी सरफेस एरिया. मींस आपको एरिया गिवन है, दैट इज सरफेस एरिया इज गिवन है, दैट इज 1500 mm square. So what we have to calculate, we have to calculate the MRR. So how we can calculate this MRR? For the MRR, this will be equals to I into E equivalent अपॉन रो इक्विवेलेंट अपॉन एफ इनटू एफ, सॉरी. ओके, तो देखिए अभी तक लास्ट क्वेश्चन में क्या था कि आपको रो इक्विवेलेंट के लिए आपको बाइनरी अलॉय की डेंसिटी आपको गिवन थी, बट यहाँ पर आपको बाइनरी अलॉय के लिए जो अलॉय बन रहा है चारों मटेरियल के साथ, ओके, उसकी डेंसिटी नहीं गिवन है, बट इंडिविजुअल आपको डेंसिटी गिवन है उनकी, दैट इज इन केजी पर, सॉरी ग्राम पर सीसी. प्लीज कीप इन माइंड दिस इज इन ग्राम पर सीसी. ओके, सभी के लिए ग्राम पर सीसी में. तो आपको यहाँ पे क्या करना पड़ेगा, रो इक्विवेलेंट कैलकुलेट करना पड़ेगा. ठीक है, आपको सभी के लिए एटॉमिक वेट और वैलेंसी गिवन है, सो यू हैव टू कंसीडर दैट परसेंटेज भी यहाँ पे गिवन है आपको चारों का. ठीक है, तो यू हैव टू कैलकुलेट द E equivalent, just put the value of E equivalent and the rho equivalent over here. I is also given to you 1000 ampere, F we already know that is 96,500. So get the value of MRR, put over here. SA is already given to you, get the value of feed rate. Okay, बहुत ही इजी है लेकिन थोड़ा सा कॉम्प्लेक्स है. ठीक है, सो दिस लेंदी है, कॉम्प्लेक्स भी नहीं है. ठीक है, सो थैंक यू सो मच गाइस. इन द नेक्स्ट वीडियो विल स्टार्ट द नेक्स्ट टॉपिक. थैंक यू सो मच फॉर ज्वाइनिंग दिस सेशन.